Alrighty, we are on lesson number 79, and it is symmetry. So this part starts on page 502, which you can sort of see. And this says, in nature, we often find balance in the appearance and structure of objects and living things. For example, we see a balance in the wing patterns of moths and butterflies. We call this balance reflective symmetry or just symmetry. So here's our picture. Symmetry, it's the same on this side and this side. So if we took this, fold it in half, it would line up exactly. And it's the same on each half. So the dashes across this drawing of a moth indicate a line of symmetry. So this dashed line is a line of symmetry. The portion of the figure on each side of the dashes is the mirror image of the other side. If we stood in a mirror along the dashes, the reflection in the mirror would appear to complete the figure. So if I put a mirror right here, which I don't have a small mirror, but I used to. Let's see. I don't know where a mirror is. But if we put a mirror here, the reflection would be the same as this. So it's the same on both sides. Some polygons and other figures have one or more lines of symmetry. So example A says, which of these polygons does not have a line of symmetry? So we have a rectangle, a triangle, a rhombus, and a square. So, well, I guess they call it a polygon. We haven't talked about rhombuses yet. Whoops. So we have A, our rectangle, B, our triangle, C, our polygon, oops, and D, our square. Try my best to make it as even as possible. So this says that this rectangle has two lines of symmetry, because if we folded it this way, it would match, and let's see, if we folded it this way, ouch, that it would match. So we could fold it in half, it would match, fold it kind of like how we fold our paper, hamburger style, hot dog style. The triangle, if I had drawn it nice and even, would have one line of symmetry because you can fold it in half this way. If you fold it in half this way, it's not going to match up. It's going to be a little bit different. This one, if you fold it this way, you have this little bit of extra. If you fold it that way, this space is all empty. But our square, we can fold it in half or fold it in half that way. So C is not symmetrical. It does not have a line of symmetry. All right, example number 2 says, copy these letters and draw each line of symmetry, if any. So we have the lovely letters, capital letters, that spell out chair. And they only did their eye like this. All right, so if we were to fold a C in half, if I made it nice and perfectly even, we could fold it in half that way, and they would line up if I drew it, if it looked like the one in the book. But our handwritings aren't always symmetrical. The H, if we put that dotted line, that symmetry line right down the middle, we could fold it in half and they would fit perfectly. Same thing with this A. We could fold it in half and it would fit perfectly. Oh, the H can also go that way. Again, if I had drawn it nice and symmetrical. H we can also fold that way and it would fit. I, we can go right on down the middle there. It'd be a small little bit, but it would still fit next to each other. Or we could go across and this way and it would still fit symmetrically. But the R, if we go across, if we fold it this way, there's this extra bit that's left over. If we fold it this way, it does not match up. So these are our symmetrical letters and these are their lines of symmetry. And those are our examples. And This says the symmetry illustrated in examples 1 and 2 is reflective, so it's like a reflection in a mirror. Another type of symmetry is rotational symmetry. A figure has rotational symmetry if it matches its original position as it's rotated. For example, a square has rotational symmetry because it matches itself every quarter turn. So quarter is 1/4, which is every 90 degrees. So if we turn it 90 degrees, if we turn it 90 degrees, it's the same. Turn it another 90 degrees, it's still going to be a square. Same with the letter H, but it has a 180 degree turn. So we can turn it full upside down, it'll be the same way. So that is called rotational symmetry. If you can rotate it and make it stay the same shape, that's called rotational symmetry. So this says, which figure does not have rotational symmetry? So we have an equilateral triangle because all those sides and angles are equal. We have a rectangle. We have, let's count these, 1, 2, 3, 4, 5, 6 sides, which means it's a hexagon. And then we have an isosceles triangle because these two sides are the same. So equilateral triangle, rectangle, hexagon, and isosceles triangle. What does not have rotational symmetry? So I'm going to try my best to draw these shapes. They're a little not the best, but that's okay. B, C, D. So if we turned this triangle around, if we flip it, it would still stay the same because you can flip it as much as you want. It would still be the same kind of triangle. The rectangle is kind of like the H. If we flip it up, it's a little bit different. If we flip it 90 degrees, just a little bit different. But if we flip it 180, it would go back to being this rectangular shape. And this, we can turn it on every side and it would still be the same shape. Same with this triangle. Now this triangle, if we turned it, if we turn it, sideways, it's not the same. If we turn it another 90 degrees, still not the same. And if we turn it another 90 degrees, it is not the same. So it is not rotational symmetry because you need to do a 360 degree turn. These you can do every 1/3 of a turn, so so this, every time you turn it on its sides there, it'll be the same. Once you turn it back, this one back on its long edge, it'll be the same. If you turn this on every edge, it'll be the same. This one does not do the same thing until it is all the way 360, which does not equal rotational symmetry. That one's a little confusing, but let's go on to lesson practice. I'm going to do A, D, and H. Alright, so it says to copy each figure and draw the lines of symmetry, if any. And let's do boop, boop. So this one, if you fold it right here down the middle, it would be the same. If I drew it symmetrically, it would be the same. Now I couldn't go across because this side up here is not the same as this side. And letter D is the letter W. Now these two sides are the same, so I could just fold it right down the middle, again if I drew it perfectly, and it would be symmetrical. So these are the lines of symmetry. Now letter H says which figures in A through F have reflective symmetry. So what can you continue to turn so it would be the same? So if we have this, we continue to turn it, it would be this way, oops, then it would be this way, and then it would be that way, so it is not reflexive. The W, again, we could do that way, we could do that way, that way. It is not reflexive. But let's say we have the letter X. We could do, well, that X, we could do X that way, which if you look at it, let's see, it's not symmetrical yet because it's in the book, the one that's drawn, it's not symmetrical yet. But if I turn it another 90 degrees, it would be the same as the first one. So that one has a reflective symmetry. And those are it for our examples. So if it helps you to draw them out, I would just draw them out at about 90 degrees turning, because that's usually what it'll be if it's reflexive or reflective. I keep saying reflexive. But these ones I believe I'm doing with you today in your homework. So stay tuned for your homework. Please ask questions. I'm here to help. If anything doesn't make sense, if you need more help on some other problems, let me know. I try to pick out the problems that I think that you still have a hard time with, but let me know. Ask me questions. And stay tuned for homework.